Today's lesson is going to be on correlations among variables, and more specifically, we're going to be looking at correlational research, spurious correlations, and confounds. So let's take a closer look at correlational research. When we're looking at the slide, this slide returns us to figure 1.4 from lesson 1. When we're looking at this graph, we see that there is a lot of uncontrolled variables in correlational studies. And because there are a lot of uncontrolled variables, correlational studies can lead people to miss relevant associations. For example, this slide shows nearly a zero correlation between the number of cell phone subscriptions and vehicle deaths. As we can see, the dots on the graph are very much scattered and they're not close to each other, so it might appear that there's zero correlation between the number of cell phone subscriptions and vehicle deaths. So on the surface, it might appear that this is evidence that shows that cell phones are not causes of more serious crashes. But there could be other factors that are at work that obscure the real pattern. So in this case, it might be that as the number of cell phone subscriptions increase, so did improvements in the safety of vehicles overall. So while the vehicles were keeping everyone safer, the risk from cell phones was still increasing, but it's hidden in this graph. So in that case, experimental studies can help tease these factors apart. So I want to make some key points about the limits of correlational studies. In correlational studies, it's impossible to show that something about cell phone use causes driving accidents. And there are some benefits to experimental studies, including how researchers can isolate one aspect of cell phone use and use experimental method to assess causal impact on driving in a true experiment. And in a true experiment, the independent variable, or IV as we shorten it, is manipulated and participants are randomly assigned to groups. Okay, now let's look at some examples. A man named Kingsbury published an article in the Huffington Post claiming he found a causal relation between early childhood education and crime. He concluded that we're taking children away from their mothers too soon. And this is how he explains his research to the Huffington Post. He says, I went to the Department of Education and got a list of kindergartners, and I went to the safety department and got the crime report. In general, the towns with a kindergarten have 400% more crime than other towns in the same county. In every county, the towns and cities with kindergarten had more crime. Can you think of any other explanations for Kingsbury's conclusion that towns that have kindergartens are more likely to have more crime? Let's look at some examples that students have provided for us, and they've watched this lesson, so they've provided some examples as to why towns that have kindergartens also have a higher crime rate. One of them says that many both parents need to work in lower income towns. This means that they can benefit by being able to put their child or children in a kindergarten so they can get to work earlier. Also, in lower income areas, probably they have a greater population density and a higher crime rate, which brings us to the next point, which says the real culprit here might be the density of the population. So the areas that are less rural and higher in population, like big cities, more that have more an urban setting, they have more crime, and it really doesn't have anything to do with the number of kindergartens that are in the area. Now, I want to introduce the topic of spurious correlations. What this means, what spurious correlations are often, which means that it means that often two or more variables, they're varying together, but it wouldn't really make sense to conclude that one of the variables causes the other one. And spurious correlations show us how people can misinterpret correlational studies. Here's some examples. For example, this one is going to be per capita cheese consumption, and this correlates with the number of people who died by becoming tangled in their bed sheets. The per capita cheese consumption is on the left side, and it's shown in the red line right here, and the number of people who died by becoming tangled in their bed sheet, that one is the black line, and we see that they're going up together. So when we're looking at this, we might think that as the years go by, they both go up, so they might be correlated, but it wouldn't really make sense to conclude that. Let's look at another example. This one is going to be people who drowned after falling out of a fishing boat. And this correlates with marriage rate in Kentucky. So the fishing boat deaths are in red, and the marriage rate in Kentucky is in black. They both seem to be going down, but again, it wouldn't really make sense that one of them causes the other one. It would just be silly to conclude it. And the next one is going to be U.S. crude oil imports from Norway, and that correlates with drivers that are killed in collision with railway train. Again, they're both following a very similar path, but it wouldn't really make sense to say that one of them causes the other one. Okay, now looking at this graph, as I said before, there are a lot of uncontrolled variables in correlational studies, and this can lead people to miss relevant associations. For example, this slide with all the scattered dots all over the graph, it shows that there's no correlation between the number of cell phone use and deaths because of car crashes. And on the surface, it might appear that this is evidence that cell phones are not causing more serious crashes, but there could be other factors that are at work and they're hidden, which skews this pattern. So in this case, it might be that as the number of cell phone subscriptions increase, so did the improvements in the safety of vehicles just overall. So the vehicles were keeping everyone safe, but the risk from cell phone use while driving is still increasing, but it's hidden in this graph. So experimental studies are going to help us tease these factors apart. So what are some correlations you may have heard that imply one variable causes another, but it probably doesn't? Okay, and this ends lesson 3. I hope you guys enjoyed it. The next lesson, lesson 4, should come up soon. And I hope you have a great rest of your day. Thank you.